Hello everyone and welcome to another devlog. In this video I'll be showing my progress that I've made since the last video that I uploaded quite a while ago. You will notice that the actual application has changed quite significantly. I believe the previous video was me demonstrating me rendering an earth. As I mentioned in one of the previous videos, I'm currently working on my final year project, and so what happened is that I changed my idea or the project I was going to be developing due to some requirements that I didn't want to deal with, so I kind of changed my idea. But here is the application. It's going to be a 3D model viewer with lots of debugging features and lighting, light manipulation, and I'm trying to make this an application which anyone can use. You should not have any, someone who has no technical ability or knowledge would be able to just as easily use the application as someone who knows what they're doing, technically. So here's the application in its current state. I have two objects rendering. These are considered each unique objects, as in each. So, for example, we have in this example we have two instances, right? And an instance is simply a translation. It's a matrix. It's a 4x4 matrix. When it comes to things like the actual model data, the material being used, as in the combination of albedo, also known as diffuse, normal mapping, specular, that's all those three combined is one material. So we have an object, a material, we have a pipeline, and then we have the instance, none of which know about each other. They're all independent areas, right? The benefit of this is that what we could do, let's say we want to render in the future, implement instance rendering, where we have, let's say, 1 million objects. We're not going to have extra. We're not going to take up extra memory using pointers or something to point to some sort of texture to use, because again, an instance is only a translation. If we want to render a specific object with a particular texture, then what we have to do is bind that texture. So what, for example, this house here, what happens is that we bind a single rendering pipeline, which is shared across all normal objects. We bind the texture, that material, and then we bind the physical vertices, the actual vertices in GPU memory, and then we draw. Now, if we were to draw a second house with the same texture, we would not rebind the texture. The texture will still be bound. We will just, what we would do is simply issue another draw call with another instance. Okay? And this other object is like a backpack. Because obviously it has a different set of textures, we have to rebind those. So rebind the material, and then we rebind the unique object. So code-wise, internally, I've made a lot of changes and a lot of improvements. One of the things, as you can see, is the UI, is the interface that I have. That has taken some time implementing, and at the moment, a lot of it is just placeholder. I also had to kind of, because applications like Blender, Unreal Engine, Unity, they are editors. They consist of basically UI elements, right? So what I was doing before, internally, I was rendering all the frames directly onto the swap chain, right? The actual a chain, basically a set of buffers that the presentation engine, right? So Vulkan internally, which is the driver, would basically handle and switch the buffers every frame and all that kind of stuff. The downside of that is we don't have a lot of flexibility when we render directly to a swap gene. So I had to do quite a lot of work to implement rendering to frame buffers instead. I had to create multiple render passes. So we have a render pass for the actual to generate the texture, which is the viewport, and then we have a second render pass which loads that texture onto the UI. The benefit of having a separate render pass or a frame buffer is that we can do anything with it. It's just a texture. We can, if we want, we can hide all the UI and render the game in full screen, right? We could have it as a little window, or whatever the case may be. We have a lot more flexibility in that regard, so definitely a positive addition. At the moment, the things I need to work on is having better usability with the UI. So at the moment, as you can see, the camera is kind of locked to the viewport, but let's say if I want to interact with the UI, what I want to implement is if I hit escape, for instance, then the camera will no longer move with the mouse, and so I can interact with the UI. And then if I, for example, click back onto the viewport, it will lock the camera again. So just stuff like that. I also want to implement a normal mapping and specular highlight. I had that in the previous video, if you remember, but because of I didn't really understand the code that well, because it was quite complex and was not designed that well, I decided to scrap it all, go back to using albedos only, re-implement the code properly, and then go from there, which is what I've done, and I just need to continue working on it. So anyways, hopefully you enjoyed the video. Graphically, not much. I would like to add shadows, be able to render like a light source, a lamp or something, and obviously have a lot better texture rendering to make an object look more realistic. So hopefully you enjoyed, and I'll see you guys in the next video. Thank you very much.